In this tutorial, we'll be recreating exactly what you are seeing on the screen. We'll be using technologies such as AI, Python, and computer vision. This tutorial is going to be a lot of fun and you will never regret watching and practicing this on your own. If you are new to this channel, kindly subscribe so that you don't get to miss my next videos. Ready to do it? Let's get right into it. Over here in VS Code, let's first look at the requirements. So I have a requirement.txt file which I'll be sharing with you guys. And in this file, I have the libraries I've installed for this particular one. So you can see we have virtualities which we'll be using to get the post model. We also have OpenCV, cvzone, and NumPy. So these are the libraries we'll be using out through this tutorial. So make sure you install them and also follow along. I have a main.py file here, and this file is the file in which we'll be writing all our codes. Also, I have a video here, so it's an MOV file, video.mov, and this is the video we'll be using, but feel free to use any video of your choice, or even feel free to use your webcam. Also, I've downloaded these models here, but don't worry, when you run the code from scratch, the code will automatically download these models for you. So don't worry about those ones. So I'll just go ahead now and import the libraries we need. All right, so these are all the libraries we will need, and as said earlier, all these requirements are in the requirement.txt file. So install them and import them as I've done here. From here, we'll go ahead and load the video file using OpenCV. So we start off by writing just cap is equal to cv2.video capture. So we create a video capture object. And in here, we give it a path to our video. So the name of my video here is video.mov. So I'll just write that, and this will get the video for me. And since it's a video, we have to write a while loop, and this while loop will help us to play this video over and over again. Okay, so after the while loop, we have here where we are getting our video frame, okay? So we have a ret variable here, which gives you either the presence or absence of a video file. So we can use it later on to do certain things. So it's a Boolean value actually. But what we are interested in is our frame here, which is our video file. So I've gotten the video file. The next thing is to just go ahead and display this video file. So I'll just go ahead and do that. All right, so over here I'm displaying the frame. So we are reading it, I'm displaying it, and we have a condition here. So since we are loading a video file, we are loading each frame per second, and also this here specified that when you press the T button on your keyboard, you want to stop the video. Okay, you want to break the whole program. So that's why this logic is here. You can change this letter to any letter on your keyboard. And also we have to use cap.release here so that we release our video capture and also destroy all our frames once we break out of the loop. So this here will load all our videos and display it for us, and we can visualize that by running the code. So here we go. So you can see it's a simple video of myself just trying to show my body turn around and nothing else. So nothing fancy. So this is a video file. We have loaded it successfully, and you can see at the end of the video everything just goes off. So in case we don't want that, we can add another condition here. So we will use the ret variable. So we'll say if not ret, which means if our video is done playing, we want to reload it and play it again. So we can do cap is equal to cv2.video capture again. And over here, we'll give it the same video file again, okay? So we'll do video.mov. And this will play this video repeatedly. So when the video file is done playing, this will repeat it again. So it will be playing over and over and over again. Okay. So this is the first part done. Now we are done reading in our video file, and that is done. We can also go ahead and resize this video file. So I'll resize it into the same variable, which I'll use the cv2.resize function. And over here, I'll give you my frame and the size as a tuple. So I'll give it a size as 640 by 720 maybe. If it's not looking good, I can just change it. Okay, so now let me run it once again and make sure everything is working before we move to the next part. Okay, I think this size is good. This size is good. If your video file looks good, there is no need for resizing. So I think this one is good, and this will keep on playing over and over and over again. Unfortunately, it stopped. It never continued. So let's see. All right. So yeah, after this, you can put continue here so that it continues with the rest of the code. So this will ensure that it continues to play over and over again. So let's try it again. Okay, started with this, and let's see if it will break out or restart again. Okay, you can see it started again. So this time around, it will not break. It will restart the video if we are out of frame. So this is the first part of the tutorial. Now we have loaded our video, we've resized it. So it's time to apply pose detection. So first, we have to initialize the YOLO model we want to use. So for that, I'll come down here and write model, and this model will create an instance of the YOLO we've imported. And inside here, you have to choose the particular pose model you want to use. So YOLO have variety of different pose models, but I'll be using the nano one, or we can try some couple of them. So YOLOv8 and hyphen pose, okay, .pt. So this is the one we'll be using, okay? So we are using the nano version of the YOLOv8 post module. And if you don't want to use the nano, you want to use the small, you can just put X here. If you want to use the medium, just put M here. If you want to use the biggest one, which is the largest one, put L here. So the bigger the model, the higher the latency. So you have to make sure, based on your computation resource available, you choose the appropriate model. So I'll be going with the nano one. Okay, now we have initialized the model. The next step is to feed in our video frame into the model so that the model will be able to detect the pose on the video file for us. So let's go ahead and do that. So I'll come here and write results is equal to our model, and inside here I'll just give it a frame. And once we give it a frame, it will process this frame, and we can even go ahead and also plot this particular frame. Okay, so what we'll do is that we'll say our frame here is equal to results at the first index dot plot, and this will go ahead and plot whatever pose it has detected on the body for us. So let's give this a try. So you can see we've successfully done the pose detection. So now we are detecting the pose. So everything is working as expected. So the next part is to get the key point from this pose detection. So we have to be able to get all the key points from this particular pose detection. And what we'll do is that we can just iterate through our results in order to get the key points. So we have a lot of points, and for that, I'll make reference to this particular image right here. So this is how the pose module work. You can see this on this image. Let me get rid of this. On this image, we have a lot of numbers, and to access a point on the human body, you have to be able to access a particular number. So for instance, if I want the nose, then I have to access the number 0. So let's first get this key point, and we can iterate through it and be able to plot this on another blank image. So what I'll do is that I will use a for loop for key points in results at in the 0 dot key points data. This will be able to return us all the key points. And after getting these key points, we want to convert it to a numpy array. So this is a Python tensor. So we have to be able to convert it to a numpy array. So it's very easy. What we'll do is key points is equal to the same key point dot CPU. And this will just convert this to numpy array, and don't forget to add dot numpy here. Okay, so this will now convert our values to a numpy array for us. Okay, and we can go ahead and use them instead of PyTorch tensors. All right, so now we've gotten this key point, and before we even try to go any further, let's create a blank image on which we'll be drawing all these key points. So I'll come back here, and I want my blank image size to be as my frame size. So what I'll do here is to come down here and now write width, height, and this is equal to frame.shape. And over here, I'll take the first two, which is the width and the height. Okay, so this will return, normally when you get the shape of the frame, it will return width, height, and the number of color channels. Okay, so it will give you width, height, and 3. 3 stands for the color channels in OpenCV. So after getting the width and the height, now we can go ahead and create our blank image using this exact width and height. So I'll type blank image, and our blank image is equal to np.0. So we use numpy zeros in order to create a black image. So I will give it our width, and we'll give it our height, and after giving that, we'll also give it our color channel to be 3. All right, so it takes this actually as a tuple. So let me just add another set of parentheses, and inside here we can specify the data type. So d type is equal to np.uint. Okay, so this is our blank image now, and if you want to visualize that, we can also do it right here. So we can go ahead and also visualize this blank image. So I'll just paste here, and I'll call this let me just add x here and add blank image. So let's run this code and see if we can also display our blank image. And voila, here we go. So you can see we have a blank image which have the same shape as our original image. So now we have to be able to capture these points and draw them on this particular blank image, okay, so that we can just render the skeleton version of whatever we are getting onto this blank image. So I'll close this program just by clicking T on my keyboard because we've added that functionality. Close the terminal, and now I will continue with the key points. So over here, the key points contain some couple of things. So the key points contains X, Y, and confidence. So for every point you see here, for every point you see, let's say we want to find, we take the nose for instance, to give you the X coordinate, the Y coordinate, and the third coordinate is let's call it Z coordinate, but in this case it's not Z as we think, as in a 3D coordinate, but it's Z in the form of confidence. So we just get that particular confidence value, and we can detect based on that confidence. So I'll go back here and also look through the key points. So I'll say for I and key point enumerate, so that we can also get the index, which is the numbers, and display it. So we'll enumerate, and we'll enumerate key points. Okay, so this will help us now to get our index, our key points, and now we can go ahead and unpack this value. So we can unpack X, we can unpack Y, and we can also get our confidence. This is equal to our key points. All right, so now that we've gotten this, we can now go ahead and draw circles and also draw our skeleton based on our confidence. So if you want to choose a confidence, or if you just want to draw, you can go ahead, but I would like to draw based on confidence threshold. So for that, I'm going to do if our confidence is greater than, let me start with 70%, so 0.7. So I'll only detect points that have the confidence of 0.7. Okay, and this should be confidence and not continue. All right, so that's it. So if that is the case, I'll go ahead and draw a circle. So this circle will just take our X and Y values, and then we'll also go ahead and put some text there, which is the numbers. So for the circle, let's go ahead and do it. All right, so I've drawn the circle, and this circle, we give it our blank image, we give it the X and Y. So this X and Y normally comes in float value, so we have cast them into integer, and then we give it the radius and also the color. Finally, I've given it a thickness of 1, so you can give it a very big thickness, but I think 1 looks pretty good. And from here, we can also put a text. So let me just put a text, cv2.put text. All right, so I've placed the text on the blank image, and this text will be the number of that particular point. So we've chosen a font here, has a simple, and also I've given it a color of white 255 to 55, and I've used CV2 the line AA. Okay, so you can feel free to play with this particular arguments. Okay, so from here now we'll go ahead and define our coordinates. Okay, so all the points on this particular human body have their particular coordinates. So I'll just create a very big list containing a lot of tuples, and these tuples will be a point for a particular part on the body. Okay, so let's go ahead and do that. All right, so I've named this connection, and the connection is a list, and this list contains a lot of tuples having our body points. Okay, having the points on our body. So 3, 1 here means let's go back to the image. So 3 and 1. So over here 3, you can see we have connection from 3 to 1, and 3 here is the left ear, and 1 here is what? The left eye. So I've just connected this in the form of tuples so that I can use them to draw this particular line. So over here, you see we have 3, 1, we have 1, 0, and when we go back to the image, you can see 1, 0 here correlates to left eye and the nose. So from the left eye to the nose, so probably the next one will be 0, 2. So over here you can see 0, 2. So I've done it for the whole body parts, and that's our list here containing tuples. So what I'll do is I'll do for part A, let me call this part A, and what part B in my connections. I'm going to do is to unpack the values. Okay, so I'll get the x1 and y1 and also the confidence. So don't forget the confidence. So over here, I'll not call it confidence. I'll just call it conf1 is equal to key points in the key of part A. And I'll do the same thing for the part B. So over here, we'll just paste this, and instead of x1, we'll have x2, y2, confidence 2, and here will be what? Part B. Okay, so to draw a point, you need x1, y1, and x2, y2. So we'll draw from x and y, which is one point, to another point. So we are looping through this to get all of these points so that we'll be able to use them to draw. Okay, now speaking of drawing the line, we have to also draw based on the confidence value. So I can check here and say if my confidence, okay, or if my conf1 is greater than 0.5. So you can choose your threshold. I'll just choose 0.5 here. And also conf2 is also greater than 0.5. So if this condition is true, then I'll go ahead and do cv2.line. Now I'm going to draw this line on our blank image. And then I'll also cast these values. So first I'll cast x1 to integer and also cast x2 to integer. All right, so if the condition is true, we go ahead and draw a line. We give it a blank images, and also we make sure we cast our x1 and y1, x2, y2 values back to an integer, because mostly they are floating point numbers. So I cast them back to integer, and I use them to draw this line. Also make sure our thickness is equal to 2. So this will loop through all these connections and go ahead and draw this for us. And after this, now we are done. So we can also just run this to test it out to see if these points will be drawn on our blank image. All right, then here we go. So this is working. Wow. Okay, so you can see there are some fluctuations. The model is not able to detect under certain harsh conditions. All right, so I'll quickly stop this, and the last and final thing to do is to start these images together. So this is where cvzone comes in. So over here, we'll use cvzone to start the two different images together. So I'll call it output, and output is equal to cvzone dot stack images. So in the stack images, you give it a list of the images you want to stack. We want to stack our frame and also our blank image. And over here, we want to the number of columns to be 2. We want the scale to be about, let's say, 80%. All right, so now instead of showing our blank image and our frame, we'll just show output and we'll comment out our blank image. So this should do the trick by just showing only one output, which contains the 2 different frames stacked together. So here we go. So we have the actual video here and the blank image representing whatever the model is seeing. So this is working great. This is how cool it is, and this is how simple you can create something like this. If you like this video, make sure you give me a thumbs up and also subscribe to the channel. I'll put the code on GitHub, so make sure you check out the link in the video description so that you can leverage this code and use it on your own. Thanks for watching, and I will see you in the next tutorial.